Hi everyone, and welcome to Activity 17. Today we're going to talk about 17.1, which starts on page 225. Now, as we move into graphing our trigonometric functions, again, we know that we talked about some previous vocab words like period and amplitude that are really important when it comes to graphing our periodic functions. Now, if we are trying to graph sine of x, okay, we got to think about around the unit circle what our values of sine are in order to help us with these values. So if we take sine of 0, we're at 0. Sine of pi over 4 is square root of 2 over 2, which is about 0.7 if we approximate. And then sine of sine of pi over 2 is 1. And then we kind of start seeing, okay, 3 pi over 4 is square root of 2 over 2 again, which is about 0.707. Back down to 0 at pi, then negative 0.707, then negative 1, back up, and we see that one period of our graph. Now, again, given that periodic nature of our graph, we know that this is going to keep repeating itself, this pattern of going to the negative values as well. And again, these are just coming from the decimal approximations in our calculator as we find the sine of each of those, right? So our domain of the sine graph is all real numbers, right? Negative infinity to positive infinity is going to work out any x value we plug in. The range, however, is between -1 and +1 because we never go above those values for our y values, okay? The amplitude here is 1 because we go 1 unit above our midline at y equals 0 and 1 unit below. And then the period is 2 pi, is how long it took us to make one full revolution in our graph, right? There are no vertical asymptotes in this that we have to worry about. Again, hence why our domain is all real numbers. And we have a minimum value in our graph from 0 to 2 pi occurring at -1 is the y value there. So from 0 to 2 pi, if we're just looking, that would be from here to here. And that happened at x equals 3 pi over 2. So that's where our minimum value was occurring over that interval. Okay. Now, if you flip to the next page on 226, kind of using that information, if we notice the values of 3 pi over 2, pi over 2, negative 3 pi over 2, pi over 2, and 5 pi over 2 all have the same y value of 1. And the reason for that is the fact that they are all coterminal to each other, right? If we added or subtracted 2 pi to each of these, we would get the next answers. That makes sense why their sign then is all the same, because they're officially, as we move around the unit circle, at the same spot. Now, talking about symmetry of our graph, if we tried folding this over the y-axis, it would not reflect upon itself. But if you turned this graph upside down, it would look the exact same. So it is not symmetric to the y-axis, but what it is symmetric to is, not symmetric to y-axis. What it is symmetric to is the origin, because it rotates 180 degrees, or is symmetric to the origin, which we know means that actually that means this is going to be an odd function. So bringing back some unit 2 information. Now, is this graph, again, which we kind of answered above, and then when we're talking about even versus odd, again, we go back with this piece being symmetric to the origin, and when we're talking about increasing, decreasing, we have different intervals in which we are increasing. So from negative pi over 2 to pi over 2, we're increasing, or from 3 pi over 2 to 5 pi over 2. So again, you want to think about kind of like on a roller coaster going left to right, where would I be increasing? Well, again, that's from these values, negative pi over 2 to pi over 2, or another interval would be from 3 pi over 2 to 5 pi over 2. On the flip side, we are decreasing as well at these points here. So from negative 3 pi over 2 to negative pi over 2, from pi over 2 to 3 pi over 2, we're decreasing. Okay, so again, left to right, you're kind of going down on the graph. So negative 3 pi over 2 to negative pi over 2, or another interval would be from pi over 2 to 3 pi over 2. Now we also want to consider our graph of cosine. So again, very similar to the sine graph, if we start plotting pieces of cosine of 0 is 1, cosine of pi over 4 square root of 2 over 2, cosine of pi over 2 is 0, and then negative square root of 2 over 2 and negative 1. So as we start graphing, again, we see that periodic nature that our first graph took, or piece took to get to 2 pi to make one full revolution. And again, because this graph is periodic, it's going to repeat itself in that it's going to keep repeating in nature all the way around, okay? Now, our domain, again, is all real numbers from negative infinity to positive infinity. We don't have any asymptotes, no holes, life is good. Range is the same as it was for sine. We're between negative 1 and 1. Amplitude is 1, and the period is 2 pi. Now, in this case, as we look from 0 to 2 pi, one interval in which it is increasing on that interval is from pi to 2 pi. It was decreasing from 0 to pi, but from pi to 2 pi, it is an increasing function, right? And when, in this case, the symmetric qualities of our graph is going to occur to the y-axis this time. Okay, we can fold it over the y-axis, and we will see the symmetry there, which means that this is going to be an even function because of that. And again, that comes from being able to fold it over our y-axis here. Now, if we notice here that the relationship between the sine graph and the cosine graph, they just honestly appear to be horizontal translations of one another, because they have the same period, they have the same amplitude. It just is all a matter of where are you starting at. With our sine graphs, we started at 0 and started our pattern. With cosine, you started here at that positive amplitude value of 1, right? We were 1 unit above that. So we see that they just look like shifts of one another, because if we took this graph, we could transform it actually into a sine graph. Which is why if you ever look on your graphing calculators, if you're trying to create eventually like a regression of things, we usually actually always talk about these in terms of sine versus cosine. So like notice in your calculator, you have a sine regression versus a cosine regression. It's because cosine could officially be transformed into sine. Now, moving on with this stuff, then we have the parent functions for sine and cosine. So really important that you know these, because then moving forward, a lot of times all we're doing is transforming based off of this information. So think about our unit circle and those 4 main quadrant values. When we talk about the graph of sine, we start at 0, go up, down, down again, back to the beginning. This is our parent function of sine. For cosine, it's nearly identical when you think about the axes, right? It takes one full revolution around, would be 2 pi. This time, though, with a cosine graph, we start at 1 and then go down and back to the beginning. So again, they just look like translations of each other. And again, we go up to positive 1 and down to negative 1 when we think about these parent functions, okay? Now, from there, we can use the parent functions to help us look at translated graphs. So notice here we have our original parent function of sine of x here. And notice we are changing the amplitude into sine of x, right? So we notice it's twice the size of our original parent function, and thus looking at the graph, the table, you can see that value as well. So what's basically happening is we are changing this parameter out front, which we're going to notice is going to stretch our graph vertically, right? It's going to stretch it so that that amplitude is changing. Now we also have some other graphs we want to look at. So again, if we have cosine of x as our normal parent function, we know that normally it would look like so, would be our parent function here of cosine, starting at 1, going down and back up, right? Here's our parent function. And again, that process would just keep repeating each other as we moved on to 4 pi as well. Well, if we are adding 2 to our cosine graph, what we're doing is we are shifting our graph up, right? You're kind of changing that parameter d, so that now instead of the midline being here at y equals 0, we're changing that so that our midline is up here at y equals 2. So we're essentially just taking our graph and we are moving things up 2 units. So we would be up here and then back down. Everything's being transformed up 2 units so that our graph would look like this. Moved up, shifted up vertically. Okay. Now, example B here then says, okay, describe what's going on. Well, again, g of x is a translation up 2 units. Now, the next page also talks about a different type of transformation. So again, in our parent function, we're starting at 1, and then we go to square root of 2 over 2, and we finish out the rest of the table, right? Moving around our circle. If we were to find, instead of the cosine of 0, the cosine of 0 minus pi over 4, aka cosine of negative pi over 4, we would be at square root of 2 over 2. And if we were at cosine of pi over 4 minus pi over 4, we'd actually be finding the cosine of 0, which is 1. So if we compare these two charts to each other, essentially what we're noticing is these are all shifting. How are they shifting? Well, they're shifting kind of to the right here. One box to the right each time is where we're seeing that value now turn, which again goes back to the idea of when you're minus pi over 4, that's shifting things to the right pi over 4. So it's a phase shift, or aka a horizontal shift, to the right pi over 4. So our original graph, again, if we're going off of the traditional parent function values, which you should label, would have looked like this again: pi over 2, pi, 3 pi over 2, 2 pi. Well, if we're shifting everything to the right, this would now all look like this. Okay. AKA pi over 4 units. All right. Last but not least, using our sine graph, again, we're kind of looking here. What do we predict is going to happen here? Well, this one is going to be a phase shift, aka a horizontal shift. Call them phase shifts in periodic functions. We're moving to the left pi over 2 units. So again, if we look at our traditional sine graph, parent function wise, we know that it starts at 0, goes up, down, back to the beginning. But when we're shifting it to the left pi over 2, we would now be moving it all over this way. So left, up, down, back to beginning. Okay. So a couple of key pieces here with the check your understanding at the top of page 229 is the idea of our setup here. We haven't talked about parameter B yet, but what we did talk about was A, C, and D. Okay, parameter A is going to affect your amplitude. Okay, and we'll talk about reflections as well, in this case over the x-axis that's happening, but A affects your amplitude, and the absolute value of it is the amplitude of your function, whether it's stretching it or shrinking it. Stretching is the example we looked at in here. B we will talk more about in later lessons. That's going to affect your period. But C, which we talked about, is going to be your phase shift, aka your horizontal translation. But we call them phase shifts for periodic functions. And again, these are the ones that are a little bit backwards because plus C means to the left, minus C means to the right. And then last but not least, that value out, uppercase T, that is for your vertical translations up or down, which are a little bit more literal. Plus D means you're moving up, minus T means you are moving down. Okay. Now, just a note for your calculator, make sure if you are graphing some of these, you're going to want to probably consider these in radian measure, since we're using pi over 2. So for instance, with sine of x, you want to make sure in radian measure, and then zoom trig is going to fit this so that it's kind of in that parent function mode. And if you look at your window, you will, table. I want to look at the window. Notice it's going to a little over 2 pi here, and we're going up by pi over 2 each time because that's what that 1.57 is showing. It's about half a pi. So just as an FYI, if you look at it this way. If you are going to look at this in terms of degrees, which normally we don't, normally we look at these in radians, you would have to make sure you would change your mode to degrees and then also rezoom so that it adjusts your window to using degrees. Otherwise, it won't make any sense. Okay, so again, zoom trig, zoom 7 is going to be helpful for you adjusting your window. Okay, I know that was a lot of information, but especially getting these parameter values A, C, and D down are really important to have for the lesson. Okay. Thanks everyone for watching. We'll work more with this in class.